All right, thank you. Okay, my name is Krauss. I'm going to talk today about game development with JavaScript. Not using any libraries, no plugins, just plain JavaScript. And I think that's pretty empowering to just use the core language to build a game, because there's so many good libraries out there that abstract away a lot of the stuff for you to build cool games. But we're going to build a single-player Pong using just JavaScript here in the next 30, 40 minutes. This won't take a whole hour or anything. We'll get you out of here quicker. But let's get into it. So I work for a company, not yet. This is me on Twitter. I'm the code boss, because I just am. This is the company I work for. It's a company local. We're about just a mile up the road, named Clevyr. We've been around since 2009. We are a consulting company with software engineering. We have a design team as well, but we build websites, web applications, mobile applications, anything software we do for clients. We have some internal products in the works too, but anything kind of data-driven is where we want to go. We do build little marketing sites here and there, but we try to go for bigger projects, kind of the more fun data-driven type things. I've also got 3 shirts here that Clevyr, our company, has made. So if you've ever seen me before give a talk, I like to throw out t-shirts. This is kind of one that I've got on right now. It's the Wheeler District, kind of Ferris wheel area. Probably tough to see from far away, but I've got one of those in here. We kind of do an OKC themed t-shirt. So I've got a few of those, and I'm about to throw one out. You just got to answer one of my questions, right? So I work for a company, I work for Clevyr. Last year in July, Clevyr created a sister company called Clevyr Labs. And we do a lot of fun stuff that's related to what we're doing in this group right here. Does anyone know, if you get a shirt of Clevyr Labs, if you can guess what we do? Games. Boom, there we go. So we build games, and I've got random sizes here. If they're not right, hit me up on the Techlahoma Slack. James mentioned Techlahoma, and I'll get you the right shirt if it's the wrong size. So we build games, but it's not only games. We specifically do virtual reality and augmented reality things. We've only been around for about 6 to 8 months or so. We've got 4 games in the app stores right now, the iOS App Store and the Android Google Play Store. They're phone games, but they make use of augmented reality. They're pretty cool. You can use Google Clevyr Labs, and you can check them out. We're working on things with the HTC Vive right now. So far, it has been games, but we've also got some other projects, such as an interactive business card, that when you scan the back of our business card, a cool augmented reality scene fires up. I can demo that after this. I've got one in my wallet. Anyway, that's me. That's Clevyr Labs. I got 2 more shirts to throw out later on. Let's get into things a little bit. Feel free to ask me questions throughout the whole time. I'm not a game developer. I do websites, web applications, pretty much anything but games. That's a whole different paradigm for me. So I wanted to make a New Year's resolution to kind of get into it a little bit. And this is kind of the basis of that talk. I did some tutorials online where I built a breakout game, like the Brick Breaker game, in just plain JavaScript. And then we built it using another game engine, which we'll talk about later, using an actual game engine. And it's been pretty fun. But this is kind of a simplified version of that breakout game, just single-player Pong that we're going to build right here. So I'm sure plenty of you here are game developers, or at least know more than I do about it. But I kind of broke up the little simple principles of game development in ways that I could understand them. And I just kind of broke it down in 4 ways. You have a game loop, just something that is constantly running, constantly updating each frame over and over again. This runs quite often. You handle user input. That's pressing a button, clicking a mouse, moving around, anything. A game is not a game if it's not interactive, and that's what you do. You handle user input. There's a lot of variables. You have to maintain the state of just about everything. A lot of game engines and libraries will help you with this, but as you are going to see in plain JS here, at the end of it, we're probably going to have about 15 to 20 variables just floating around that all keep track of things. And there's math, which is kind of the coolest part for me. Again, not being a game developer, we don't do a ton of math, at least I don't, in a lot of my work. When I'm building a front-end application that communicates with an API, there's really not much math in there. So it's cool to kind of get back to just math roots with game development. This is where you need some physics knowledge, just general geometry knowledge, and we're going to mess around with a little bit of that today. It's fun. And it's cool that you actually get to use math skills with game development. And we've got a game developer at Clevyr he's crazy talented, and he's a math major, and he knows more than I could ever hope to imagine. So it's cool just to talk about it, too. Anyway, these are my 4 principles. If you were to talk to an actual game developer, like the guys at Goldfire Studios here, I'm sure it's very different. But for a noob, this is what I like to think of it as. So the rest of this talk is pretty much going to be some coding. So we're going to build single-player Pong. You guys ready? All right. And also, this is all going to be in JavaScript, so if you've never messed with JavaScript before, this will be a good intro to that. Again, no libraries, this is just core JavaScript. There's new features in what's called ES6. We're not even going to use that. We're using like as core JavaScript as you can get. Don't worry about this. This is the actual presentation I'm talking about right now. We have a single view file here, and it looks like this. This is going to be our thing, and this is our canvas right here. We're just going to draw on that. And this is the file that's pulling up right here. Now, if you've ever seen HTML before, it's nothing crazy going on here. We just have our head element inside there. We've got a little bit of styling that just gives the background of our canvas a gray color. In our body, we've got our canvas here with the ID of my canvas. We'll reference that later. And this might seem a little complicated, but it's nothing to worry about. Basically, I've got in the code directory here, we're going to step through this. I've got different files. Each one kind of adds more code to the next, and this just loads up whatever file happens to be the last digit of my port number. So I'm on port 7000, so it's loading up the first file that we're going to talk about. We'll kind of keep adding code incrementally. It's magic, I promise. Okay, so let's get into it. So the first concept of a game is we need a game loop of some sort. So that's what we have here. We don't have anything going on, as you can see. Nothing's happening here. But first, we're going to access our canvas. In JavaScript, you have access to the document object whenever you're dealing with the browser. We're going to get the element myCanvas by its ID, so that's the canvas element. And after this line, we're really never going to use this canvas element again. We just need to get what's called the context of it. And we're getting the two-dimensional context. There's kind of 4 options that you have here. You can get a two-dimensional context. You can get WebGL context, which WebGL is a feature in a lot of newer browsers that allow you to do kind of 3-dimensional graphics, a lot more powerful stuff. There's WebGL 2, which I don't really know what the difference is between that and WebGL, and there's a bitmap context as well. We're using 2D because we're just building Pong. And everything we do with this canvas, we're going to reference this context. That's what CTX is. Okay, the next thing here is we've got our draw function here, and we've got this function called request animation frame. We did not define that, as you can see. The next shirt goes to anyone who can name what request animation frame might do. And it's okay to be broad. Anyone want to take a guess? Bam, you got it. You got it, man. All right, and you got the Lucky Wheeler District Fair shirt that I got on. We can be bros. And again, if it's not the right size, hit me up after the meetup, and I'll get you the right size. We've got plenty of them back at the office. All right, we got one more shirt left. We'll do after the demo. Okay, so request animation frame. We need a game loop of some sort. The best way, the most agreed upon kind of best way to get this in JavaScript is using this request animation frame function. And what that is it tells the browser, hey, whenever it's okay for you, whenever it's most optimal, I want you to run this function. And we've got a draw function in there. And JavaScript functions are first-class citizens, which means we can pass them around as variables. So this draw references this function we have up here. So we're telling the browser, hey, whenever it's okay for you, run this function. And ideally, you're going to be animating things in here. That's kind of the purpose of it, to tell the browser, usually right before a repaint of the page, run this function. And it's not running it, 1 time a second. It's running it ideally at 60 frames per second. That can change if your browser's under heavy load, depending on the resources, but 60 frames per second is that's what you can usually guarantee. And it's not necessarily bad if it goes slower than that because the rest of your game would slow down. It's like if you have lag, pretty much. That's just less frames. Okay, so our draw function is going to be where we do all of our stuff. This is running at 60 frames per second. And you notice at the bottom of it, we're calling request animation frame once again with the draw function. By default, this is not a loop. This just tells the browser, hey, 1 time, run this function. So we have to keep running it over and over again in our draw function. So while I said nothing is happening on this page, it's actually not true because we're running a function 60 times per second right here. The function just doesn't happen to be doing anything. So let's make it do some stuff. We've got our game loop set up here. Let's make it do some stuff. So the first thing we want to do with Pong is let's actually draw a ball. So we'll step through that. Every bit of each file is going to be adding on to itself. It's the same file. We're just adding on new code. So and I've tried to break it out to where it says new code and end new code, so you can see what we've added. So at first we've got some variables here. Our first 3 variables related to the game, not including these top 2. So we're going to track x and y. These are 2 variables that will track the center of where the ball is going to be. We set the x equal to the width of the canvas divided by 2, and we set the y equal to the height of the canvas minus 30 pixels. If you ever see a number, it's usually pixels. Now, with canvas, by default, your coordinates are going to be in the top left corner. So when I say x is the canvas width divided by 2, that's going to be halfway over here. When I say y is canvas height minus 3, well, if I do height, that refers to all the way down here. I'm sorry, minus 30. And when I take away 30 pixels, that's going to put us somewhere around here. So ideally, this kind of center bottom area is where we're going to position this ball from the beginning. And then we need to track the ball radius, because when the ball collides with walls and the paddle, we need to know, we don't want to track the center of the ball getting hit, we want to track the edges. So we need the ball radius. And then we've got a function that's going to draw the ball. So using canvas, this is how we're going to draw the ball. We're going to begin the path, and again, notice we're using the context of the canvas, not the element itself. We're never again going to reference that canvas element on the very first line. We're telling the context, we're going to begin a path. This just means we're going to start drawing something. We're going to draw an arc. There's no circle feature in Canvas, but an arc will get us a circle. We've got 5 arguments here. We're going to tell the arc we want to start at these 2 coordinates. This will be where we start the arc. We want it to tell it the actual radius of our arc, which is going to be 10. And then these next 2 are, we're getting kind of into that math geometry zone. These are going to be the beginning and end radians of our arc. So if you remember from high school geometry, a circle, it starts at 0, if you're talking about the right side of it, 0 radians, and if the full circumference of a circle is 2 pi radians. So that's what we're doing here. So we're telling it math.pi, we have access to the math object in JavaScript, times 2, so 2 pi. And that's going to draw our circle. We're going to tell the context that we want to fill it with blue, and then we're going to tell it that we want the circle to be blue. By default, this would just be a stroke around the circle. We're going to fill the circle, and then we're just going to close the path. Bam, we've got our draw ball function. And then in our draw loop, in our main loop, we're just going to draw the ball. We're going to call this function. So at 60 times per second, we're going to keep drawing this ball over and over again. It might seem crazy right now, but you'll see why in a little bit. So we've got our ball there. It's magic. And you can see it's kind of where we told it to be. It's at the middle of the canvas, and it's all the way down minus 30 pixels. All right, we've got our ball. Maybe we should try to make it move a little bit. We're not going to do any collision detection yet. We'll get to that in a minute. Let's just kind of make it move. So let's hop up to the top of this file. So we've got 2 new variables here, dx and dy. This refers to delta x and delta y, going back to high school. And if you took a physics class, this refers to displacement, which can be negative or positive. We're going to use these variables to say on every single frame, which is firing 60 times a second, we want the ball to move in the x position 2 pixels and the y position negative 2 pixels. So that's going to move it, if we are looking at the ball here, on the next frame, it's going to move it over 2 pixels and up 2 pixels because it's a negative value. Because again, y starts here. And we've got our 2 variables. Let's actually use them. If we go down into our draw function, this is all we have to do. We just have to, because we're drawing our ball on every single frame, we just have to update the x and the y variable, and we just need to add dx and dy. So even if dy is negative, which it is here, that's going to subtract from the y, even though it looks like we're adding it. So let's take a look at this. We should be moving a ball around, but you may have noticed already just by looking at the code, we may have a little problem, and that's that we're not really moving a ball around. We're just drawing a new ball every single frame, which makes it look like a line here. So what do we need to do? We need to, on every single frame, we need to clear, at the very least, we need to clear that ball area, but we're just going to make it easy and clear everything, every single frame, 60 times per second. And this is going to be the easiest update right here. It's just a single line. Just at the beginning of our draw function, which is our main loop, we're going to tell the context that we want to clear a rectangle, which we're just going to set the rectangle to be the whole height and width of the canvas. So this is our beginning coordinates, 0, 0, which refers to this top left corner here. And then the next two arguments refer to how far over we want to go to the right, which we want to, if we set the canvas width, that is the whole width of the canvas. And we're going to set the canvas height, which will say we want to clear everything starting in this zone from here to here. It's everything. So let's take a look at that. So now, after we're clearing the canvas on every single frame, and then we draw the ball, we should actually see a ball moving around. Bam, we got a ball, but it shouldn't just keep going. It should actually hit the bounds there. So let's do our first collision detection. I'm pretty excited about this, can you guys tell? All right, we're going to do collision detection now. We're at the top of the file. Now, this is really not too difficult at first. It may look a little bit messy, and game engines make this easier, but it's not too crazy yet. So what we want to do with collision detection before we dig into the code, we want, whenever the ball hits this boundary on the right side, we just want to change the x direction, because that's what it means to hit a boundary. It just changes the x direction. We want that to happen on this boundary as well, the left boundary, and also on the top boundary. Top boundary will change the y direction, so instead of going up, it'll go down as soon as it hits this wall. We don't want to do anything with this bottom boundary yet, because that's going to be kind of our game over boundary, which we'll handle on our last bit of code. So we got 3 boundaries we need to handle. And let's handle the x boundaries first. So right here, we've got some code. If the x position of the ball, the center of the ball, plus where it's going in the next frame, that's that dx, is greater than the width of the canvas, so we're kind of talking about if the x of the ball is somewhere over here, minus the ball radius, because we don't want to, the x is measuring the center of our ball. We don't want, half the ball to be off the screen before it bounces. We want the very tip of it, which is how we're going to measure the radius. So we have the width minus the ball radius. So if that, basically, if this fires, that would mean that on the next frame, our ball would go beyond that right boundary. So if that happens, then we'll come back to that or. Then we want to just change the x direction. The or here is for the other boundary. So if the x position of our ball plus where it's going in the next frame is less than the ball radius, that means that it's going to be on this boundary over here, because the canvas width is 0 over here, so we don't need to account for that. But if the position of the ball is less than the ball radius, then that means that it's gone over on this boundary a smidge, and then we want to change the direction. For the y value, we do want to do pretty much the exact same thing, swapping out our x variables for our y variables, but we don't care about the bottom frame, which correlates to this x value right here. We only care about the top frame, which looks pretty much exactly like the left boundary, because those are the 0th values for the y. So if the y of the ball plus where it's going is less than the ball radius, because the y up here is going to be 0, then we want to change the y direction. And it's as simple as that right now. So let's take a look at what this is doing. And we should see as soon as it hits that, bam, we've got just changing direction. And it looks like it's colliding with it, but all we're doing is, and you don't get to see it hit this wall right here. But it's pretty easy to do that because we've got everything extracted out into variables. I'm going to hop to the beginning of the function, and let's just set the dx to a negative value. And then by default, that's going to just change the initial direction of the ball. Yes?
Did you change the background color to be darker? I think maybe there's not enough contrast or something.
Oh, okay, yeah. Let me see. Yep, let's change it to, let's see, that's a little bit darker. Let's check that out. Is that good? Okay. Thank you for calling that out. When I get in the zone, I just keep going, man. Okay, so one more time. Let's just watch that ball bounce gracefully. So magnificent. Okay, so we've got our ball there, and the ball's behaving kind of like how we want it to. So our next step is going to be to draw the paddle. So let's get a nice red paddle in there. I think we were on app-4. Let me verify. Let's move that back. So now we're going to draw a paddle. So just kind of like we drew the ball, we've got a couple more variables here, a few actually, 3 more. We're going to track the height of the paddle, which is going to be 10 pixels. And we're going to track the width of the paddle, which is 75 pixels. And then we're going to track a variable called paddle x. This is referring to the left position, the left side of the paddle. And this is important because we're going to manually move the paddle, so we need to know where is it at on the page. Like, what's the x position of the paddle? That'll help keep track of that. We don't need to keep track of the paddle y because paddle just moves left and right, not up and down. So we've got these variables here, and the paddle x is set to the canvas width divided by 2, but instead of that, it's set to the canvas width minus the paddle width. If we just set it to canvas width divided by 2, kind of like we did for the x of the ball up here, that would offset the paddle to where the left boundary would be in the center of the ball, not the actual center, the center of the canvas, not the actual left boundary of the pattern. I think I'm confusing it myself here. Well, let's just see. I'll show you. So if we were to remove that, bam, it looks like it may be in the center, but it's not. This is the center right here. By removing the paddle width, we can set it in the center. Magic. But I've skipped ahead of myself. I haven't even shown how we're drawing this paddle yet. Let's do that. Okay, so going on down, just like we have a draw ball function, we have a draw paddle function. It looks pretty much identical. In fact, it is, except for instead of drawing an arc, we're drawing a rectangle, which is a little bit easier than an arc. Kind of like how we cleared the rectangle at the beginning of our draw function, there at the bottom of the screen. We tell where we want this rectangle to start, the top left coordinate. So we give it the paddle x, that's the initial value of it, the initial x value. We tell it where we want the top of the paddle to be, which is going to be the canvas height minus the paddle height. And what that allows us to do is if we set it to go down to the paddle height distance, that means it's going to look like it's just sitting right at the bottom there. So we've got the top left coordinates set with these first two arguments. This tells us how far over to the right we want to draw the paddle, and then how far down we want to draw the paddle. We've got those extracted to variables. We want to fill it red. It might look weird that I'm setting it to a color and it's just working. You can use a hexadecimal value. You can use an RGB value. You can use anything that CSS would use. But red, there are some default variable names like red or gray or black. Those will work as well. So that's why this actually says the word red as opposed to like a hexadecimal value. We want to fill the rectangle just like we are with the ball, and then we're ending the path. And bam, we've got our draw paddle function, so the last thing to do, nothing's calling this yet, so the next thing we want to do is call that draw paddle function. And this is the last bit of code. So in the draw function, just like the ball, we're going to draw the paddle 60 times per second. And bam, there it is. All right, but we can't do anything. Even if the ball were to hit the paddle, it's not going to do anything. It's going to go right through it. But even worse than that, we can't even move the paddle. So let's get this paddle moving. So this piece is going to look like a little bit of code, a little more than what we've been doing, but it's not complicated. All we're going to do for this first little 25 lines or so, I'm going to try to get it on the page. Okay, we can pretty much get it on the page, this chunk of code. All we're going to do here is we need to track when you've pressed right and when you've pressed left. So let's do that. We've got another variable as well called paddle dx. That's just like our dx and dy for the ball, but we only have a dx because, again, we're not moving the paddle in a vertical position. We're going to set this on every frame. We'll move the paddle 7 seconds, or I should say every frame that a key has been pressed. This is significantly higher than the 2 that we set the ball to, because it would be kind of mean if the ball was moving faster than the paddle, because then you would have to anticipate where it was going to be. It'd be a much more challenging game, I would say. So in every frame, if a key is pressed, we'll move the paddle 7 pixels. We've got 2 variables here, right pressed and left pressed, and these are going to track if a key has been pressed right now. So we've got 2 function handlers here. This one will fire if any key at all has been pressed down, and the next one down here will fire if any key has been released or pressed up on. Before we get into those, I want to show you how we link those up. In JavaScript, again, you have access to the document object in a browser, and you can there's a function on there called add event listener, which allows you to listen for different events, like click events, mouse move events, key press events, key down and key up, which is what we're using here. So we're hooking in an event listener that whenever a key is pressed, it doesn't matter which one, whenever it's held down, we want to fire the key down handler, and this will fire just when you press it down. And then when you release it, key up handler will fire, which is down here. So let's look at what the key down handler is doing. By default, the function that you're passing in here, again, JavaScript, you can do functions are first-class citizens, so you can pass them around as variables. by default, an event argument or parameter will get sent to this function. So that's why we have access to this event variable right here. And on a key press event, it's got an attribute on it called key code, so we can see what actual key code was pressed. For the right button, the machine code is 39. For the left button to be pressed, that's 37. So that's why these variables are the way they are. So we know that when a key has been pressed and the key code matches to 39, that means the right button's been pressed. And because we're in the down handler, we know that you're pressing down on the right key. So we're setting the variable right pressed equal to true. If instead you click the left button, which is the left arrow key, which maps to the key code 37, we're going to track if the left key has been pressed. And then very similar ideas with the key up handler. If you've released the key and the key that you just released was the right arrow key, we're going to say right pressed is false because you're no longer pressing the right key. Same thing with left key. If you've released the left key, which has a key code of 37, we're going to set that variable to false. So a lot of code here, about 25-ish lines of just trying to track what you've pressed. What's the status of left and right? So let's actually use it now a little bit farther down. I'm going to skip down a little bit. And our new code added is going to be right here. And it's very simple right now. If in our draw loop, again, this is firing 60 frames per second, if the right press is equal to true, that means you are actively pressing down on the right key. Then we're going to update the paddle X with the paddle DX, which is 7. So every frame that you've held down the right key, the paddle is going to move to the right 7 pixels per frame. If the left key has been pressed, we're going to subtract the paddle DX from paddle X. That will move it in the opposite direction. It'll move it to the left. And that's it right now. And this is firing in our draw loop. So if we load this up, then I can move our paddle around. Bam. It still does not have any collision detection. You can see the ball just went right through there. And we need to solve that problem. But before we do that, let's solve another problem, because if I just keep holding down right, my paddle goes off the screen, and that's not okay. Again, it could just be making the game more difficult, but I'm going to say it's not okay. We want the paddle to stop whenever you hit the bounds over here. So let's do that first. So we just added this if statement in our previous code. If right's pressed, update the paddle X. Add to the paddle X. If left's pressed, subtract from the paddle X. We just need to update those a little bit and say if the right's pressed and your paddle X, which is the left boundary of our paddle, plus the paddle width, which means we're now on the right boundary of our paddle, is less than the canvas width. So what we're saying here is as long as you're pressing right and the right boundary of the paddle, which is right over here, is less than the canvas width, then we'll allow the paddle X to change. If it's not, which would only happen either if you're not pressing right or if your right boundary is beyond this boundary or right at it, then we're not going to change. We're not going to allow paddle X to be added to. Very similar thing with the left side, except we instead of tracking the right boundary of the canvas and the right boundary of the paddle, we want to track the left boundary of the X and the left boundary of the canvas, which is going to be 0. So we just need to check if the left boundary of the paddle, which is our paddle X variable, we just need to make sure it's greater than 0, and that will say that it's beyond, that this left boundary is beyond this left boundary of the canvas. If it is, then great, we can change paddle X. If not, we're not going to let it happen. So let's take a look at that. All right, I promise I didn't just let go. I'm holding down to the right key. Let's try the other side. Bam, it stops. So once it is at that boundary, no longer will we allow paddle X to change, at least in that direction. So we've got everything working pretty well so far, except let's actually make it collide with the paddle. And this will be our last chunk of code. We've got one other addition after this, but it's pretty simple. So this is going to look pretty complicated, I know, and we're going to take this slow, I promise. So the only things we added were these 3 lines right here. Previously, and I'll hop back to the previous file, we're editing this area right here. Previously, we're only tracking the collisions for the Y value if it's hitting this top boundary. Well, we need to change the Y direction now if it hits this paddle boundary, but not specifically. It specifically is this paddle boundary between the left area and the right area. So that's kind of 3 conditions. The ball's got to be greater than this left boundary, it's got to be less than this right boundary, and it's got to be either at or below this boundary of the paddle right here. So that's 3 conditions, and that's why going back to our new file here. That's why we have added these 3 lines right here. So this first line just checks the top boundary of the canvas. That was already there. We didn't mess with it. These 3 lines check the boundaries of our paddle. So this first line is going to check the top boundary, that's this area up here, that line. And we're going to say if the y value of the ball plus where it's going to go in the next frame is greater than, which means below, the canvas height minus the paddle height, which means, so this is the canvas height, paddle height means right here, the very top of the paddle, minus the ball radius, because again, we don't want to track if the center of the ball has been hit, we want to track if somewhere along the radius of the ball has been hit. So if that has happened, and the x of the ball is greater than the paddle x, which means x of the ball has got to be beyond this left boundary, and the x of the ball has got to be less than the left boundary of the paddle plus the paddle width, which is the right boundary of the ball. I'm sorry, the right boundary of the paddle. So all those 3 conditions have to happen, and if they do happen, then we're just going to do the same thing as when it hits the top boundary of the canvas. We're just going to change the y direction. And lo and behold, this should work. Wait for it. Wait for it. We did it. We did it. All right, we've got a pretty much basic Pong game going on here. We've done all the hard stuff. The only thing we're missing, well, there's a lot that's missing, but the only thing else we're going to do is some type of a game over feature. Right now, if the ball goes beyond the bottom of the boundary, the game just kind of stops, and we have to refresh the page to do something. So let's actually, we're still just going to refresh the page, but let's do it automatically now. If the ball goes, so if it goes right there, let's just refresh the page. That'll be our game over sequence. And that's our last file we're going to edit here, and it's nothing crazy. We're just going to edit. So this is the code we just added here, where we check to see if the boundary of the ball has either hit the top boundary or the paddle boundary. We just want to check to see now. Otherwise, if the ball itself has gone beyond the lower boundary, so now we're officially handling that lower boundary. We're doing that with an else if condition here. So if the y value of the ball plus where it's going in the next frame is greater than the canvas height, that means that the center of the ball would be, and somehow that happens. I just can't explain it, but it's like a free life, right? If the ball goes beyond this bottom area here, the center of the ball, then we just want to refresh the page, and that's what we have here. Just like we have access to the document object, we have access to location, just some free gimmies that the browser gives us with JavaScript. So let's just reload the page. Another nice thing about the request animation frame is, we can go and load this one, but if I go to a different tab, we'll make sure that the game over animation works. Okay, bam, it works. Another nice thing about request animation frame is that if I hop to a new tab, it slows down those frames drastically. I think it's maybe 2 frames per second, maybe even not at all. But if I hop back here, it should pretty much be where we left it off, so you can see that. It does that for efficiency reasons, again, because request animation frame is supposed to be for animations, and an animation's not good if no one's seeing it. So if you need like a timer, for example, running, don't use request animation frame, because if you switch browser tabs, that timer's not going to fire. But for something like this, a game, it's perfect. So that's our code right here, and we built it all just using core.js. Now, there are other game engines you could be using. There's a handful of them out there, and you get a shirt if you can name just one of them. And this is our kind of downtown skyline shirt. It's got the Devon Tower. It's got the river down there. This is our initial Clevyr OKC shirt. So wear it proud. Yeah.
Enchant.js.
What?
Enchant.js.
Boom. There you go. And again, if it's not the right size, just let me know. Enchant.js is a common one, and there's a chunk of other ones. Another popular one is Phaser, and I know there's a couple people here who are pretty good at Phaser, much more so than myself. So I built, this is a fun little demo. It kind of sprung from me building a breakout game using just core.js, and I want to show that demo off real quick. And I've got the code for it, but let me just show the demo of it real quick. Okay, and you can see it looks pretty much identical. I did a couple little fancy things, like changing the color on every frame. It looks pretty magical, I know. And I sped up the ball every time it hits the paddle. And there's a couple other things too, like scoring and lives. just little things that I didn't want to cram into this one talk. But you can see this, and this is the core of the game is exactly what we just built. It's you can tell it's pretty much identical, except maybe just color differences. It's not perfect because you can tell that when the ball collides, it's not hitting the radius, it's hitting the center. That would have been a pain for me to kind of track which angle it's hitting at and everything. But let's look at the code just for a second. It will probably look very similar to the things we've done. We've got all of our variables here. It's a 187-line file, which is not crazy for a whole breakout game. I'm going to hop to the next frame. You can see we're tracking everything with it's a two-dimensional array, a matrix, if you will. For the bricks, we're tracking the statuses. We've got the same key down handler, key up handler. We've got a mouse move handler here as well, because when we move the mouse, bam, it does it too. We've got a little collision detection function. We've got a drawing lives function. I'm going through this quickly because I think I don't want to dig into how this is working. I want you to more see just kind of what it looks like to code in core JS. Because what I'm trying to get at is this is not super pretty to build a game like this. You can do it, absolutely. We just did it. But there are other tools out there that make your life better if you use them. Going into this, that's pretty much the rest of the file that we've already built. But I built this in Phaser as well, and I went through a tutorial to do this, and it's actually like 35 less lines, and the game itself just plays much better. So this is the game built in Phaser, and right off the bat, you can tell it looks a little nicer. And one of the cool things you can do with Phaser and pretty much every other game engine is it handles auto-scaling for you. We didn't have that, so we kind of have a responsive game here. We've got nice little animations going here. The game is just much smoother. Like, look at that. We've got jiggling. We've got tweens going on. It's just a much more fluid game. The ball actually changes direction based on where we hit the paddle. I didn't have that in the other game, and it changes speed and everything. It's so much more fluid. And we've even got a much better game over scene. You actually have to click to continue on after you lose a life. I enjoyed coding. Once I got the hang of Phaser, I enjoyed using that quite a bit. And let's step through that code a little bit. And again, I won't take a ton of time, but I think let's hop at the beginning of it. Just kind of looking at it, I think you'll see this is probably what you expect when you are talking about game development. You don't have to necessarily write your own collision detection. It handles those for you. You just give it kind of hooks of what you want it to do when two things collide. We've got our variables. That doesn't change. We've got 3 functions here. Preload, that need to fire before the game renders. That's kind of where we would unload in our images. Whenever the game gets created, we run a function. Then whenever the game gets updated, we run this function. That's going to be our main loop, more or less. So again, we've got we still do have a lot of variables here, a lot of tracking of everything. But if you look at what's going on here, we want physics to enable. That's something we couldn't do with just core JavaScript. We're setting the anchor of the brick to be in the middle. That's what this is saying right here. So we don't have to track the left boundary the whole time. We're actually adding bricks using a nice English readable function, the add function here. We've got a function when the ball leaves the screen. Just looking through this, it still certainly looks complicated, but as we kind of go through this, we've got we're playing animations. You can read that here. Phaser and other libraries make this much easier, and it makes you feel like, I don't know, it made me feel like I was an actual game developer instead of just a noob. We've got sprites in here. Again, just the whole physics engine and everything, it was fun to add. And then just at the bottom here, we've got collision detection. So what I was saying is whenever the ball collides with the bricks, we run this function. Whenever the ball collides with the paddle, we run this function. We didn't have to do any interesting math check boundaries. It just handles that. So there's plenty of game engines out there. This one was built using Phaser, which is, I think, one of the most popular two-dimensional engines out there. And if you want to know more about it, don't ask me. Ask James or Benji here, who've been doing this stuff for years. I'm just doing it for like a couple months. Another game engine that I just want to call to light is, and it's a game engine, but it's also just a 3D engine. It's called Babylon.js, and this one's pretty cool. I built a little demo in this a couple years ago, and it somehow still holds up. But so I'm going to load that here. But this is kind of where I learned just the basics of three-dimensional gaming. And this probably looks complicated. Oh, we're out of the skybox. This probably looks complicated, but I built this in like 2 or 3 hours, just going through a tutorial. These game engines make this stuff super easy. This is just a texture. It's the topography is using a heat map, which is just a black and white PNG, which kind of tells you what you want the height of everything to be. The water was a little bit tough, but again, I just followed a tutorial, and this is Babylon.js. Again, just, and I don't have the code that I can show you here, but I've got it on my GitHub, and I'll post a link to that. It's not a ton of code. I want to say 100 to 200 lines of just kind of just configuration stuff. So let's say that I'm sure you guys are more talented than me. If you don't know JavaScript or you want to kind of learn this stuff, I've got some resources for you. First of all, if you want to learn JavaScript, these sources are awesome. Code Academy here is one of my favorites because it's mostly free. I say mostly. It's free until you want to pay for it. There's certainly premium levels, premium courses. Code School is wonderful. They've got free courses. Most of it's behind a paywall, but these both focus on interactive coding tutorials. So you're coding, you're getting feedback. Pluralsight is video courses. They're phenomenal. You learn a ton from them. They're not interactive, but they're just phenomenal videos, and I think you do need a prescription for all of that. And you can just Google up learning JavaScript. It's a good tool. It's a good language to learn. Yes, good call. Free Code Camp is a wonderful place that focuses heavily on JavaScript, not strictly, but a lot of it is JavaScript. And they meet here in this room every Sunday at 2 p.m. for an hour, every Sunday. And it's free, so if you want to go, just come on by. If you want to learn JavaScript game development, you can type in this URL, which will bring you right here. And this is verbatim. This link right here will tell you how to build that breakout game I built, that I just showed a second ago. This one is a step-by-step tutorial that shows you how to build the one in Phaser that I just showed you. This is literally what I did to get my feet wet with game development. And there's a couple more games here that are even more awesome. But this was my starting point, and I thought it was just a phenomenal resource, just a simple blog post about taking it step by step, just like what we did. So that's the link, or you can just Google game dev with JS tutorial, and it will be there. That's all I got. I don't have any more shirts. That usually means I'm done talking. If you want to find me, I'm the Code Boss on Reddit, Twitter. I try to be everywhere. There's another guy who shares the handle, like the website, and I'm not a fan of his. But he also has the GitHub, which is just annoying. But I've got Instagram and Twitter and Reddit and all the other ones. My website is thesociety.org because I don't have the Code Boss yet. I blog, I do random things there. So that's all I got. Feel free to ask me questions. Again, if you got a shirt and it's not the right size, let me know and we'll figure it out. So that's it. All right, we got any questions?
Well, just curious, you had the key values hard-coded to 39 and 37.
Mm-hmm.
So JavaScript doesn't have constants for that?
I could certainly have extracted that out to a variable, but by default, as far as I know, there's no. I could create like I said, I create a variable that just sets it. But as far as built-in constants with just kind of core JS, I don't think it does.
There's a string representation you can access. I think it's like key value or something like that.
Okay, and it would be like right key or something.
I can actually show you in a minute when I'm showing off the
It's just the magic number.
Yeah.
39.
Well, exactly. Yeah, and at Clevyr, for example, we try to stay away from magic number. That's what we call them. Keep everything as a variable. Yeah.
The animation function that runs, what was it, 60 frames a second?
Mm-hmm.
Is there any way to alter that to 30? I mean, I don't know why you would, but 30 frames a second? Or?
I don't think so. And again, I'll probably defer to
Alter the...
Yes. I'm terrible at repeating questions. The question was, can we change how fast request animation frame fires? I don't think so. I think that's a browser set thing, and again, it tries to do it as optimally as it can. It does usually fire 60 frames per second. You're not guaranteed that by any means. And again, if you're under heavy load, it'll fire less, but I believe not.
You're right. You don't have direct control of the frame rate. All browsers aim for 60 frames per second. If you don't have that performance, it will drop. It might drop to 30. You can also build your own game load and define how many frames per second you want it to run, but request animation frame is considered best practice.
Okay.
Very good question. All right, well, I'll stick around for a little bit afterwards, so feel free to ask me any questions. And thanks again, guys. Grab some pizza.